So I have here my joints that I require to be bonded together. What would be my shopping list for this application? Well, it would be resin and hardener, my filler, a set of pumps, mixing sticks, brushes to apply the epoxy, mixing pot, and some protection equipment. Joint design is fundamental to great success when you're using epoxy. And here we have two different examples of good and bad joint design. Here we have a butt joint where we've got two sections of end grain timber that I'm going to glue together just like this. This is a very poor joint because you can see that the surface area here is very, very limited. Whereas here, although this is a broader piece of timber, we have excellent joint design in the form of a scarf joint. And you can see the bevel on here tapers to a non-existent taper, an 8:1 bevel. That's to say that the material thickness is about 20 millimetres and the bevel is 8 times that measurement. So we've got a 160 millimetre bevel from 20 millimetres right down to nothing. Now you can see quite clearly that this broadens the amount of available surface area. Very, very good engineering. Here we've got very, very poor engineering. How are we going to bond these surfaces together? Well, we're going to use a process that we very, very often refer to in our technical literature called two-step bonding. That's to say that the first step of our bonding, we use the resin hardener mix to apply to the joint with a brush, with the objective of that resin hardener mix wicking into all the available end grain. And you can see here we've got limited end grain available, and you can see here we've got a massive amount of end grain for our epoxy to penetrate into the joint. So to execute that first part of our two-step bonding procedure, I'm going to use our resin and hardener. I'm using here the standard 205 hardener because I'm working in England and the temperature is perfect for using that. Before I start using any of these materials, I would want to make sure that I avoid skin contact. Now to do that, you can see that I'm wearing long sleeves, and also I'm going to put these nitrile gloves on as well. These are really, really durable gloves that are non-allergenic and really important when working with epoxy resin. Also, very, very importantly, I'm going to make sure I protect my eyes. So now I'm ready to do some work. You can see here I've installed the resin pump and I've installed the hardener pump. And you can see quite clearly that these have two different strokes. I'm going to ensure that I have primed the pumps. That is to say that I can just see a small amount of resin and a small amount of hardener at the spouts here. So I just do that just by depressing the pumps gently, and you can actually feel some resistance on the pumps as the epoxy comes to the spout, just like that. And the same with the hardener pump. Just a tiny amount. I'm going to discard this mixing pot, and I'm now going to use a fresh mixing pot to dispense 1 pump of resin and 1 pump of hardener. I'm then going to use these fantastic reusable plastic mixing sticks. These are really, really good for working with epoxy. And I'm going to make sure that I blend the resin and hardener together so I get a really lovely homogeneous mix of the two. If I don't do that sufficiently, then simply I will get very, very poor results. So I'm going to spend a little bit of time doing this, approximately 2 minutes. So I've now spent 2 minutes blending the resin and hardener together, and I'm now ready to conduct my work. I'll put the mixing stick back in this pot, and I use one of these really neat little glue brushes for applying the resin hardener mix to my joint to do the first step of our two-step bonding process. Now I'm hoping that you see a very, very strong colour change for the end grain of the wood, which is a strong indication that the resin hardener mix is wicking in to all that lovely end grain fibre. And you can see clearly the dramatic difference in colour change, which is a strong indicator that we've got powerful epoxy resin wicking into these end grain fibres, which will provide the maximum amount of anchorage for our joint. I'm then going to coat the other face, and you can see quite clearly again we're getting this strong colour change. What I'd like to illustrate as well is our pour joint design, because here we also have end grain and we'll also get a strong colour change, but we've got a fairly faulty type of joint, but reasonably strong, surprisingly strong, but fundamentally flawed in comparison with our lovely scarf joint. So you can see here a strong colour change compared with the uncoated end. Now this is the first step of our two-step bonding process. I'm going to leave these for about 20 minutes to ensure that the resin hardener mix has wicked into all that end grain and penetrated as far as it can do. And then I will execute the bond by mixing my resin hardener mix with some filler. So I'll return to this in about 18 to 20 minutes time. We're returning to our joints around about 18 to 20 minutes later. You can see here how the resin hardener mix is wicking into all this available end grain. There's a strong colour change here, and this is a good indication that we're going to get the maximum anchor for the second part of our two-step bonding process. So now I'm going to make a slightly thicker mix. I'm actually going to use the same resin and hardener, but I'm also going to use one of the high density fillers. This is 403 microfibers. This is a pulped cellulose fibre that really thickens the epoxy and gives us a strong, robust glue line. Now I'm going to meter out 2 pumps of resin and 2 pumps of hardener. Making sure that I spend at least 2 minutes mixing the two together. A really, really good check on your work the next day is that you'll find it's possible to break out the cured epoxy from this mixing pot. And if you found a residue of unreacted material in the corner of the mixing pot, you are simply not mixing sufficiently. That's a very, very good check on your own work. So do spend time mixing the resin and the hardener together. And I'm now going to add my filler. 1 scoop of the filler to each combined pump stroke will give you a nice kind of mayonnaise-y consistency that we want for this type of joint. Blend the two together and spend some time making sure that all the filler is blended with the resin hardener mix. So you've got a mix that actually is kind of like a mayonnaise-y consistency. This is ideal for this kind of glue joint. So I'm going to apply it firstly to the bad joint, and because I'm using two-step bonding technique, I only need to apply this to one face and then simply bring the two together. Now, to avoid any mess underneath our scarf joint, I'm just going to separate these apart and then put some sticky tape on the table. Our next step is to apply our thickened resin hardener mix to our scarf joint, just making sure that I've spread this evenly over the surface. Over larger surface areas, you might want to use a notch spreader for distributing the thickened mix evenly. But for this scarf joint, I can just use my little mixing stick. I'm now going to position that on the table. And I'm now going to bring my scarf joint in, making sure that I get that all lined up. And making sure that I get that level at this point. For the purposes of this demonstration, this is fine on a worktop, but you might want to clamp this up or secure the joint with a couple of screws or pins just to hold it in place temporarily, or maybe even a jig if you're doing repetitive scarf joints to hold it nice and true. But you can see here, if I use a straight edge on the scarf joint, I've got a nice true level surface there, and that's the most important part. It's quite important not to apply too much cramping pressure. Excessive cramping force can in fact squeeze all the resin hardener mix out of our joint. It's a really good idea to clean up whilst the resin hardener mix is still liquid. And then we'll return to these joints after a 24-hour cure, and then perhaps we can test them to see which is strongest. And so here we are with our two joints 24 hours later, and we've allowed these to cure. We have our very poorly designed butt joint here, and we have our very, very sound joint design of our scarf joint here, all bonded with thickened epoxy. Now, just how strong are these? How much can we trust in the power of this epoxy bond? Well, I'm going to do a pretty crude test. I'm going to stand on these and see if I can break them. I can't break it. Our scarf joint will be very, very strong. Now, if I increase the span of support, we might get this to fail. You can see clearly here that there's joint failure simply because of the poor joint design. There is some fibre failure right at the point where the adhesive is contacting the wood, but really this is down to poor joint design. Now, can I get my scarf joint to fail? I know this is a broader piece of wood, but this is sound joint design. No way. That's really, really strong. This illustrates to me the power and strength of an epoxy bond combined with good sound joint design.